Good morning, everyone, and thank you for joining us for the webinar today. My name is Greg. I'm part of the sales team in the SA region, and I'm going to start off today's webinar with the company introduction and discussing some of our products. Once done, I'll hand you over to Nicholas. Nicholas is part of our engineering and design team, and he will do a demonstration of the design tool. So you will be muted during the webinar. The session will be recorded and emailed to you. We also can have a 5-second poll at the end of the webinar. We'd really like everybody to complete the poll because that'll give us more information on the products that you would like us to present in future webinars. We will also have a Q&A session. If you've got any questions, please use the Q&A box. And if you want to be anonymous, please click the little tab before you send your questions. So over to Canadian Solar Company and the portfolio. So the company at a glance, the company was founded in 2001 in Canada and listed on NASDAQ in 2006. And as you can see, we've got a large solar and energy storage capacity in production. And then also we have a footprint of over 20 countries. Then in the middle section, you can see we've got a large quantity of modules and storage that we've delivered globally. And then we're also a tier 1 solar company and energy storage company under the Bloomberg NEF. And then right at the bottom, very proud of this, that we were voted the world's most trustworthy company by Newsweek in 2024. So the overview of our EMEA region, our headquarters is in Munich. We've got 4 offices and 3 warehouses. And then the EMEA, we've got over 150 employees with over 50 nationalities. We've also done shipments to over 90 countries in 2024. Our product and application portfolio, I'm going to discuss some of our modules and then also the power electronics equipment. So we don't only manufacture modules, we also manufacture power electronic equipment for residential, commercial, and also utility scale. So being able to offer this to our clients, it simplifies your procurement as well as any contract signing, credit processes, and then also it's easy to coordinate your logistics, working everything with just one company. So under our product portfolio, we've got the residential products, which is the panels, and then also our EP Cube, which is a 7.6 kilowatt hybrid inverter with 5 kilowatt hour battery bank, which is stackable. Then under our CNI, we've got the CNI panels with our string inverters, and then our Kubank. The Kubank is a 100 kilowatt PCS inverter with 247 kilowatt hour battery bank. So all in one unit, some of the key technical features, it's got active cell balancing, and then also liquid cooling and also fire suppression built in. Then over to the utilities side, we've got utility modules, also string inverters, and then our Soul Bank, which is a 5 megawatt hour containerized system in a 20-foot container. For more information on these products, please feel free to contact us and we can discuss it further for any of your project requirements. So today I'm just going to discuss our modules and the string inverters, as this is something that Nicholas is going to use during the design. So under the modules, we've got residential and commercial modules. We've got the CS6.248TD, the 54TM, and then the 66TM. This is a range from 440 watt up to 635 watt. All of these modules come with our N-type TOPCon technology. Then under our CNI and utility applications, we've got the CS6.266TB up to the CS7N TB-AG bifacial module. Again, these are with our N-type TOPCon technology and our glass modules and the solution for your commercial and utility projects. Over to our special modules. As you can see, the module definition is the same, except here at the end where we've got the H1, HP, and AG options. Also from a 620 up to 730 watts. So what makes these different is that the H1 panel is for high loads. So we have increased the frame size from 30 to 35 millimeters. Under the HP, again, the same dimension or thickness on the frame, but the glass is 2.5 millimeter, so that gives you greater hail resistance. And then on the AG module, again, the 35 millimeter frame for higher loads. So under our inverter solution, we've got a range of string inverters for your small utility scale up to your large, small commercial scale up to your large utility scale. These inverters feature MPPTs that have a 32 amp or 40 amp input. And these inverters have a 10-year standard warranty, and you can increase it to 20 years. The reason we can do that is due to our patented cooling technology, which gives you long-term reliability on the inverters. So the inverters start off at a 15 kilowatt all the way up to our 350 kilowatt. This range here for your utility scale, you'll see is a 800 volt medium voltage inverter, where the rest are all the low voltage 400 volts. Something I want to draw to your attention, I mentioned in the previous slide, the 32 and the 40 amp options. So we've got inverters that have 9 MPPTs with 32 amps. So it's 2 strings per MPPT with a maximum of 16 amps per string. If you use the panels with a larger current, we've got an option of a 6 MPPT inverter with a 40 amp per string. So that will be then 20 amps in total. For any information that you need on these inverters, please feel free to contact us. And then our Canadian Solar technical support. So we offer support to customers, installers, and distributors. There's 4 ways of contacting us. We also offer local pre-sales and after-sales support, and also installation support and on-site maintenance and support. And this way we try and offer our clients the best support on our Canadian products. So that's everything from my side for now. I'm going to hand you over to Nicholas, who will do a demonstration on the design tool.
Thank you, Greg, for a great introduction. Quickly introduce myself. I'm Nicolas Garcia, technical support engineer for system design here at Canadian Solar. So as anticipated by Greg, we are going to do a demonstration of our design tool. I'm just going to share my screen here. We will focus here today on a C&I project with our modules on our inverters. Our tool is free. Everyone can use it. You just have to register. We will share the link. It's here provided by Insan, and this is the login window. Obviously, I have already my credentials, so I will just log in. And you will see now how the tool is structured in 2 parts, maybe. The main part, plant configurator, or if you go here also to home, it's basically the main window of the tool is a part of the tool where you can design projects from scratch, including also the physical part, so all the buildings, obstacles, and so on. And we also have a second part of the tool, which is called the string tool, where we can, with very few input data, verify configurations for different combinations of our products. As Greg mentioned, we offer some combinations of modules with inverters and also the storage systems for residential EP Cube, and then we have also the Q bank. As mentioned, I'm going to start here today with the string tool for a C&I project with modules and inverters. To create a project, we go to string tool and click on new, and then we just have to input some basic data. So for example, here, webinar 4th of June will be the name of the project, then the reference as we want, and a short description which is going to be for me PV with inverters. Very easily. The important thing here is the address. In this case, I'm just going to input a city. If you have the exact address, it's always better, because then the system is going to load data from Meteonorm or from PVGs. It's going to input all the relevant information on the radiation, on the temperatures, and so on. Also important to mention that all data here that is loaded into Instant is verified by and certified by the Fraunhofer Institute in Germany, and it's even bankable. So here we've seen how the information has been loaded from the location, temperatures, and so on, and we can move to the next step. In the next step, we have to define PV fields. In this case, we can define up to 3 PV fields. We just have to input the information here and activate as many as we want. I'm just going to use 2 here, just to show you how it looks like then in the next step. But basically what we have to do is include an azimuth here by clicking on the question mark or inputting the number directly in the windows. Here I'm going to say that it's a south-facing slope, more or less, and then the tilt is going to be almost 15 degrees. I'm going to input it here by hand. Once we have it, we have to select if it's a freestanding installation or a roof mounted, and then we can choose the module. If we want to choose a custom module that it's not Canadian, we offer this possibility here even by clicking on this box and then creating a new module or selecting some modules that we have created in the past. To create a new module, we just have to input the data here manually. We can input also a PAN file directly, or we can look into the ENF database and fill automatically all the fields. Obviously, here we are going to recommend using a Canadian solar module. In this case, for a commercial and industrial project, we are going to use the 6.2 66 TV of 630 watt power class. And I'm going to select here more or less the number of modules to get, yeah, exactly 180 modules for 113.4 kilowatt peak. With this, we have defined the first field. Then we have to fill the second one. Same. I'm just going to do something similar here, similar tilt, 15 degrees, just to show you how it looks in the next step. Obviously, what the demonstration we are doing here is something invented. We are doing something that's not real, but just to show you all the features of the app. Again, I'm just going to be fast here, selecting the modules, 620 watt, and I'm going to say here, I don't know, to a little bit more, maybe 189, just so we can differentiate them. With this, we have defined the PV fields. We just have to select now the inverter. For this, we go into the inverter series. Obviously, here we have already market box that shows only the inverters that we have available. And you see how we have all our commercial and industrial inverters. Also the EPQ, it's not going to be covered in this webinar, but in this case, we're going to choose the 100 to 120 kilowatt series. And we are going to focus maybe on the 100 kilowatt inverter type B, so with 9 MPPTs. Here we have some basic input data and also some output data that then we can use to estimate the one that we have to use. Once we have it, we click on to next. And we move into the inverter configuration. The system will allow us to change the number of inverters here in the beginning. Here we will have 2 inverters with a DC-AC ratio of 1.1 more or less. We can just confirm. And here we will see the layout. We have here the inverter number 1. I'm clicking here just to hide it. And then we see the inverter number 2. Also, we can hide it. Important here is that we assign, well, here we have all the MPPTs. In this case, we have 9 MPPTs, and we have here the PV field that is going to be assigned to this MPPT. In this case, the PV field 0 is going to go into this inverter number 1. And if we go to the second inverter, we see how it's already assigned the PV field 1. This is important to balance the strings. Then on the layout here, we've already defined the PV fields with the number of modules that we have, 180 and 189. The module that we choose, also the azimuth and tilt. And Then we have on the inverters all the MPPTs. Important here to know what this means, basically. Here, for each MPPT, we have two entries. So on the rows, we have entry number 1 and entry number 2. And then on the columns, we have the number of modules that are going to be inputted into each input. So the number of modules per string. What this tells us here is that the minimum modules per string that has been calculated for this inverter and these modules is going to be 6. So if I click here on the 6, it means that we are just inputting one string of 6 modules into the first entry of the MPPT. If I click on the 10, then it's going to be one string of 10, 14, and so on. If we are going to use both entries of the MPPT, then we have to go into the second row and click on these cells. So for example, here, when we see 12, it means that we are creating 2 strings of 6 modules, and then we are inputting 6 on the first entry and 6 on the second entry. Same, if we click 10, then we have 2 strings of 20, we have 2 strings of 10. On the color code, we have here in this like green, the configurations that are respecting basically all ranges in the inverters, open circuit voltages, also intensities and power. Everything is just within the safety range of the inverter. Then we have here lighter green with a warning where it says that there's an overload that exceeds the nominal power of the channel. These configurations are still valid because our inverters can be overloaded up to 1.5 its nominal power capacity. So we see how these configurations are still valid here. When we go into the yellow part, we are overloading more than 150% the channel, so this is not going to be possible. So already the system is telling us that if we use one entry per MPPT, we can connect up to strings of 20 modules. If we choose 2, we can go up to 26 modules in 2 strings of 13. Here, the system offers the option to calculate the strings automatically. It's a calculation that is pretty random, honestly. We recommend anyway to do them by hand. Also, with a quick calculation here, we know that it makes sense to make strings of 20. We can use only one entry to do strings of 20, or we can just do strings of 10 and connect them in using both entries of the MPPT. This is for the first inverter. So we see already the PV field has assigned all the modules that it had left. And then we go into the second one, which is going to be more or less the same. Maybe we have longer strings for some of them. And there we go. Here the system will tell us if we have assigned all the modules or not. So for example, this -3 seems that we have assigned 3 modules less than 3 modules more than we are supposed to. So we just have to assign this correct, or just click calculate again, and the system will do it for us automatically. Again, this is generally, we recommend doing it by hand because of the instructions of the inverter. We generally recommend following the manually and doing it manually. Yeah, oh, exactly. Now we've got one module left. I'll just do 19 here, very randomly until we have 0 out of 189 to assign. Very quickly, I'll just go to the next step. Here again, the system will load the data that we are inputting together with the data that it has from metronome or radiation. Also looking into the physical landscape that we have on the location that we selected, and it will load it kind of in layers in order to get an output that is reliable and that we can then export into the final report that we can share with anyone, with the client, or also just for us to do our calculations. Also to mention that anytime you need any kind of support, or if you want anything tailored, just please reach out to us. We can do it. together. Also, so here in the yield results, the next step is showing the basic results of the simulation, which includes the definition of the fields, kind of an estimation of the PV energy output, the performance ratio, and so on, together with the configurations of the inverters, where it shows the strings that we have inputted per MPPT here in the columns, and all relevant values of power, voltages, and currents. If we want, we can already export this by clicking here on the top right into the print button, or we can add the self-consumption model, for example, if it's an industry, and also the financial study for the client. In the self-consumption, what we can do here is that we can input the consumption of the client, and then the system is going to use the algorithm to divide in a smart way the energy that's going to be produced into the self-consumption of the client or the storage system. If we include it, we will have a dedicated webinar, as mentioned, later on, and also it will be injected into the grid. In this case, first we have to define the consumption profile. For residential installations, the system can actually calculate it with some input data. For commercial and industrial, we will obviously recommend to uploading the load hourly profile. To do this, we just have to load a CSV file with one column with 8,760 values. I have here several loads. In this case, I'm just going to upload this profile with 150 megawatt hours per year. We can click here and view consumption profile, and you can see here how the consumption is divided by hour and by month. In January is going to be different from March, and so on. Once we upload everything, the system will always tell us to reload the graph so we can visualize the results. So, for example, here we can see it on a monthly basis, on a yearly basis. Normally, I would recommend here going to the yearly data type and seeing the average production. So this is showing us kind of an average day during the whole year, not per month, but the whole year of the production that we have here in this pink color. Also the consumption, so the load curve that we have here in this light blue, and then where the energy is going. We can see also this on the right, where we see that here the production is going to self-consumption, 30% of it, and then to be injected into the grid, almost 70% of it. If we would add a storage, or if we want to add storage, we will see this later on, but just to give you a snapshot of it, we have to click on this box. And then you will see a recommended batteries capacity. You can choose our solution. In this case, it will be Canadian Solar AC coupled QBank, and then we'll have to reload the graph. And this will tell us that the excellence will, so all this blue part will go into the QBank and so on. Again, not going to deep dive into this today. I'm just going to focus on modules and inverters. So once we have this, we just have to save, and we can move on to the financial study for the end customer and to see how the business case looks like. Again, this is loading the context of the next inputs that we have provided, and when it's ready, we can move on to the financial part. Also to mention that this is a web-based application, so it's always better to have a good connection to work with it. And we see here, basically the financial calculation very quickly. We've got first the option to change the years of economical analysis. In this case, it's 20. We can move up and down. Just going to leave it like this. And we can change also the currency. I'm just going to leave it in euros. First things we have to input are the costs. We can input these in a detailed way, including the cost per product, so modules and inverters, and then some additional costs like installation and so on. But here, generally, I would recommend using a total cost of the system in euros per kilowatt peak. I'm just going to invent something. Please don't take this as reference, just for you to see how the system works. The annual power degradation of the PV module We can see in the datasheet. Normally it's filled automatically, so in this case it's going to be 0.5% per year. And then the battery cost in this case does not apply. So we will see down here the total investment that it will be needed for this project. Then, if the client wants to finance part of the system with credit, or if there are any grants available in the country or the region that you're working on, you can input here the amount. It can be a total amount. So, for example, 10% of the project, or a fiscal attraction of an X% for a number of years. I'm just going to leave it like this, blank, and then the next part will be the last one, the electricity purchase and sell price. It has set here automatically that we are purchasing electricity at 20 cents. I'm just going to put this a little bit down, and then I will modify it later on. Again, not for any reference, but just to show how it works. Once we have the prices input and all the costs here, we can click below and calculate. And we will see how the system gives us a summary of what we have. So in this case, it gives us yearly energy consumption, energy yield, also where the energy goes, the revenue we can expect, the yearly return rate, and so on. And here on the right, it gives us a kind of cash flow diagram, which tells us that here we will be between this year 6 and 7 recovering our investment. Obviously, it's going to do something here again, increase the purchase price and increase also the sale price to 14, for example. If we can calculate, this will change. We can see how it looks. I play with it, as you see here. In this case, if we increase the prices, then we will recover the investment a bit earlier. Again, this not for reference, but anyway, we have shown how the string tool works. This we can then export by clicking the print button here. It will pop up actually in a different window I will share now. But basically, the system will generate a PDF report of what we just did, the whole thing, including how the system is configured based on our input, also the yield results, the self-consumption, including all the data we have inputted again with the consumption, and then finally the financial study. Again, this has popped up in a different window. Oh, just give me 1 second, please. And here we'll search this tab. Here it is, the report. Again, the name we gave to the project, webinar reference, and so on with date. We have also the inverter configuration with all the relevant values of the MPPTs, the self-consumption model, and finally the financial case. So with this, the demonstration of the first part of the tool is finalized. Again, please reach out with any questions. We are always happy to have a talk and to speak about any kind of design or configuration that you're working on, and also support with it. So now moving on to the next, to the second part of the tool, we'll have the plan configurator, which requires a bit more explanations. I will try to be synthetic here, but basically, again, same. You have to go into new. In this case, I'm going to input a project name. Again, webinar reference 1, 2, 3, 4 PV plus inverters. Here it's important to include the address. I have a demo here. We can select it by inputting the address here or just moving on the map. So an important thing is that we have to place this little blue flag in the center of the building that we want to work on. We can also, if we want, not show the labels. We can change the view and so on as in a normal Google Maps application. We can move the flag by clicking on it and dragging it, or we can also do double click and place it. We adjust the zoom, important also to have the full picture of the place we want to work on, and then we click on create. Here then we will get different menus. I'll try to be fast also not to show everything that the tool offers, and so you have also on the recording. Again, if you have any doubts, please come back to us at any time. First thing here is going to be the view, which is shown in the bottom part. We have the light that it's showing. Now we are in a mode that shows us the hours of the days. So we can, on the 21st of June, so we can change this bar and see the hours of the day. We can also change the day and so on during the year. But what we generally recommend here to work with is to go onto the right side and click on the top light, because the definition is generally a bit better. This one is the 2D view. We can also use the 3D view. And there is an additional one where we can see a real size kind of person on the installation. We may see this later on. First thing we have to do here, we have to work on the first menu, which is the terrain. Normally we just go to the sketcher, which is this polygon here, and we can draw the shape of the building in different ways. We can just draw a kind of polygon by clicking here on the edges of the building that we are working on. This is generally very useful when we are working with irregular shapes and so on. Also, please note when we see this black cross on top of the edges, it means that we are working on 90 degrees angles. If we want to keep these 90 degrees, we just have to press on the keyboard the Alt button and then drag the cursor. Here we will have the shape. In this case, I'm going to delete it by just clicking delete on the keyboard. Click back on the map and then use the shape, a predefined shape, because this one is pretty regular. So I already know the measurement of the measures of this building. I'm just going to input here the measure. It's going to be 38 meters this way, and this one is going to be 75. There we go. 75. We see now that the area has moved from where we wanted. So what we can do is just take this blue white dot and drag it. We can also choose the axis and drag them using the axis. And we can also choose different parts of the polygon, so we can adjust the different sides or different vertices. This one, I'm going to choose this one below, so we can then go to the right and rotate it and place it more or less where the building is. If we want to go out of the menu of the shape, we just have to click on the map, and then if we want to go back, we just have to click on the shape. Once we have the shape, we just need to create the building. For this, we go into this next step. In this case, it's going to be a flat building. I'm just going to adjust the height to 8 meters, for example, and then click on create. Then, when we have the building, we can use the transparency. So we can see the obstacles, and the obstacles is going to be the next menu. As we see here, I'm just going to place some openings which are these ones. On top of these ones that we see here. I'm going to adjust a little bit the shape. So on the menu of the shape, we can duplicate it, and then we can also scale it. So for example, here I can scale more or less a little bit the shape. If we want to adjust it again, exit the menu and then come back to this translate button. And then once we have it placed on top of the building, we can also duplicate it. So the important to duplicate it is that the red axis is going to be always the horizontal axis, so the X, and then the blue one is going to be the Y. To duplicate it, we can choose this here, duplicate. And I know that on the X direction, we just have 2 openings, and the distance between the dot here, the reference of the dot here and the reference of the dot where it needs to go, kind of, it's going to be 18 meters, 18.5 meters. In the Y direction, we've got 7, and I know the distance is going to be 10.25. So once we have this, we just click on duplicate, and we see how this has been extended to the whole building. You can now click again on the transparency, maybe go into the 2D view. To do zoom in and zoom out, we just have to use the wheel of the mouse. If we want to rotate a little bit, we can press the right button and move the mouse around, and then we can also press the wheel of the mouse as a button, normal button, and move around with the mouse again to do kind of a translation. Once we have this, we can also add additional obstacles. We can add, for example, in this case, there are some trees below that might cause some sudden wind at some point. We just get it here. I'm just going to use a maple here, as we're Canadian, and I'm just going to put them on top of them, just to see if there is any kind of shadow wind. Probably not, but to show it here. Once we're happy with the obstacles, important, we can also provide some offset to the obstacles. Now the default offset is 20 centimeters. If we see apply here, we see how there is an offset in every obstacle that where modules are not going to be placed, obviously. We can also increase this if we want to 0.5 and so on. And basically this works for any kind of object that we put on the input on the building. More things here. We can measure things with this Sketcher tool app. So in this case, we can measure, for example, the 38 meters of the building. And then we can also select different objects here with the multi-selection. So in this case, I can select these 4 openings. I could delete them if needed or modify them. I'm just going to disable it. And then I'm going to go to the prototype. Important for the prototype is that we can create different kinds of structures. Here we've got the tracker, which is a ground mounted single or double or different axis trackers for ground mounted installations for whoever wants to check them. Normally we will have to click here on custom structures for roof mounted, and we see different kinds of roof mounted structure also, including the normal ground mounted without so fixed, basically without any tracker. In this case, we are going to use a flat roof installation in a portrait way with 15 degrees. And we're going to select the same module that we had before, the 6.266 TV, 630 volts. I'm going to call this, I'm going to leave the name of the prototype as flat roof. We see this is landscape, so this is going to be horizontal. Horizontally placed, so we have it as reference, and when we create it, it goes on to the next menu. Here we can have different kinds of prototypes if we want to check different kinds of adjustments. I'm just going to use one in this case to do the fitting. Just click on this blue arrow, and then we click on the field that we have. We can select then how to place it if we want to center it, adjust it to the left, to the right, and so on. We can also give offsets to the different sides. We can actually give an offset here of, for example, 0.3 for all sides of the building, and then we see how the area is a little bit reduced. Then we go again onto the fitting module, and then we can click on calculate. Here we have seen, obviously, we have selected previously the openings here, so they are not included. And we see also how the modules are placed down south facing. In this case, because we are in the northern hemisphere in Europe. If we want to adjust it to one edge, we just click here on edge, and then we choose the edge where the modules are going to be placed. And as we see, the system recommends us to place it like this. I'm going to use this one. So when we're sure about the layout, we click on place. As we see, because we selected them before with a multi-selection, these objects have not been taken into account. But I'm going to quickly show you now how to edit this, how to delete some rows if needed. So obviously these rows are not realistic because they're going to be on top of the opening. So we can just select them by clicking on it and delete it. As usual, we can work on 2 dimensions or in 3 dimensions if we prefer so. Again, selecting these 2 rows. This one, deleting, and I think this is the last. Sorry, I deleted the whole building, which is pretty unfortunate. It's something that happens. So the next step in this case will be to create it again. I'm just going to do it very quickly. By using this, directly the polygon it's important when we click on anything on the shape on the map, it's going to open the menu of this. So if we then delete it, it's going to be deleting the whole object that we selected. So I'm going to quickly duplicate again this obstacle. Then we had 18.5 here and 2, and then we have here 10.25 and 7 objects. Duplicate. It's not doing it because it's not placed on the building. Important again. So when we have an object, we have to place it directly on top of the building that we had, as we see here. Transparency. We see the objects there, but they're not placed. They were placed in the previous building, which means that they're not going to work on the actual building that we have now. So once we have this, we see this opening has been fitted into the building that we have created it on. So again, 18.5 meters and 2 objects, and then 10.25 meters and 7 objects. Duplicate, and now we see how they're placed in the building that we have created. We have the prototype already created, so we're going to place it again, calculate it. It's already automatically taking into account, obviously, now all the objects. We're going to place them. We've got the tree here, so we can already move into the next step, which is going to be analyzing the shadow wind. We can analyze it by clicking on this sun here on top. Once we are sure of the installation, here we've got on the top right the number of modules and the total power, which is going to be 207.9 kilowatt peak. And then when we go on to the next step, we can already simulate the shading. In this case, most likely we won't have much shading by this tree. The system will show us here below. And as we see, the losses are minimum, and all the modules are operating more or less at 99%. So no losses in terms of shading. We close this window, and then we can move on to the inverter configuration. To do the inverter configuration, we just have to click on the slope, click on string design, select the inverter that we have, as we see here. In this case, I'm going to use the 100 kilowatt again, type B, so 9 MPPTs. And we're going to click on calculate. The system will then, again, make us choose the number of inverters. I'm going to choose 2. Same as explained before, the thing that we have here is that we can select the number of reference modules per string. So if we click here into 10, for example, if we click now calculate automatically, the system is going to try to adjust the string length to 10. Same if we want to click to 12, calculate automatically, then it's going to be more or less a bit more balanced. I'm just going to move with this. So we have to do double click on apply to all fields on top, and then we have to select here assign to all fields below. This shows us the smart kind of string calculation that the system has done in order to minimize the cabling, and then it will show us also here in different colors the string the system has done. And also, if we click here on select drop point, we see how the cables are going to go down to the inverters in this point. We can move also this point if we want to place the inverters in a different way. So we can calculate the minimum number or the minimum length of cable needed. Once we are sure about it, we click on Save Configuration. And then we can move on to the next step, which is the summary. In the summary, we can click on Configuration, export different drawings. We can have different configurations if we want to compare it, and then export documentation. And this is going to bring us to a different window, which is very similar to the one that we saw with the string tool, but a bit more complex. So for example, the reports are going to be including more information, more graphs than previously, because also the system has more information to work with. I'm not going to go into the details, also being conscious of time, but basically it is the same. The yield, I will show you now the report that the system does on the system yield, which is a bit more complex than the one we had before, as we see here, including also pictures and so on. And then also the losses, different kinds of informations that are a bit more complete. Technical drawings is showing also the layout of the building that we created, electrical design, the distribution of the tools, and also a single line diagram of the system. Very simple. Then we can also activate self-consumption, financial, and so on. The additional thing that this has, the plan configurator has, is that it can create for us a bill of materials, which includes everything, including the cable that we have used for the system, and then we can even input this into a commercial offer. When the bill of materials is checked and saved, we can create a commercial offer, which then can be saved and export. I'm not going to fill anything, just to show you how it looks like, but basically this will create a PDF form that we can use as a basis for an offer. Again, it created in a different window that I'm going to share now. There we go. And it looks a bit like this, with basic information, a bit more graphic, and a bit more descriptive for a customer whose main activity is probably not energy, but something different. Last thing is that we can share these projects with our colleagues, or you can also share it with us by just going by just exiting here. Also, additionally, you can download everything you created here on Excel by clicking this X on top, the top right. And you can also save the project, then exit, and share it with us or with some colleagues of yours by opening this manager here. Or directly clicking on to share here on the top right. I'm just going to share it here with Greg. Here there is Greg, Gregory Kruger, and then he will be able to see it from on his account. And we also get notified by email. So that's basically it. I've been going to speed up a little bit in the end, but I have seen some questions on the chat. I don't know, Greg, if we have some time to reply to some of them.
Sure. Before we get to the questions, we've just got a 5-second poll that we're quickly going to run through. Like I mentioned in the beginning, if you could please just reply to the poll, and then we know what to discuss in our future webinars. Okay, so over to our Q&A. Yeah, there were a couple of questions. One of them is the design tool free for use? Yes, it is to everybody. Then is there a link for the design tool? What we'll do is we'll send a link to you via the thank you email that we'll send out after the webinar. And then also, let's have a look here. Yes, the recording will also be sent to you via email of this webinar to view at your leisure. They also had some questions. Are the inverters approved for Colombia, Germany, and Austria? So these inverters have been installed in numerous countries across Europe, America, and also down here in South Africa. So they are certified IEC, the VDE, and even the South African NRS. So if you'd like to double check, please go onto our website, contact us directly, and we will double check that if the inverters are certified for your country. How to specify the azimuth angle? Is it from a given range of values? So I'd say the best thing is to Google the area, the azimuth area of the area where you're going to install. You'll get the values there, and then those values you can use when you enter it into the design tool. And then the last one, 5 megawatt storage system, also certified for use in Germany. I believe it is, which PCS. So the Solbank doesn't have a PCS. You'll use a medium skid with it, depending on, and that'll depend on the size. So there is an intake form that we send you. You fill in all the details, and then our design engineers will sit and double check all the information you've given, and then design a system accordingly for you. Like I said, that's all the time we've got for today. please reach out to us via the email or our website, and we will get somebody to contact you as soon as possible with the information that you need. Thank you again for joining us, and we look forward to seeing you in the future. Goodbye.
Thanks a lot.